We're going to look at a new rule that's going to help us differentiate even more complicated looking functions. And the new rule is called the product rule. And if you think about what product means in maths, it means multiplication. Now, if we just recap some of the functions we know how to differentiate now, for example, take this function y equals x cubed plus 5x squared. This function is easy to differentiate, dy by dx. You just differentiate each component, so we have a 3x squared plus 10x. Okay, that's easy to do. This function here, remember that, well, if you look at it, it looks like a composite function, so you let u equal the bit inside the bracket, 3x squared plus 5x, and then y equals u to the power of 3 over 2, and then you differentiate each function with respect to the correct variable, and then you multiply those two together, and then you've got the derivative of y with respect to x when you replace whatever you see back with this, right? But I'm going to show you a way to differentiate functions that look like this. We've got root x times 3x squared plus 5, and you may think to yourself, well, how do you differentiate this? You may think to yourself, well, actually, no, this is quite easy to do. I could just basically rewrite that root x, as x to the power of a half, and multiply each bit in here with x to the power of a half, and then differentiate each component, and it'll be pretty straightforward to do. And that'll be right. You could do that, okay? But I'm going to show you this new method, which is going to help us differentiate functions like this, because if you look at what this function is, this is really two separate functions being multiplied together. It is the square root of x times, and this is already in bracket, 3x squared plus 5. Okay? And I'll show you this new rule called the product rule, which is great for differentiating functions which are a multiplication of two separate functions. So if y equals two functions being multiplied together, u times v, then dy by dx equals, and this is the product rule, u times dv by dx plus v times du by dx. Okay, so this is the chain rule. This is the product rule. So if y is two functions being multiplied together, like this one is here, then the derivative of y with respect to x is the first function times the derivative of the second function plus the second function times the derivative of the first function. And I'll explain to you how we're going to use that now to differentiate this quickly. Okay, so you could go expanding this bracket by multiplying each term by root x and so on and adding the powers together. But this product rule just speeds up the method. Okay, first thing is to determine what the two u's and v's are. Okay, so u clearly equals the square root of x. That's this function here. So then v would have to equal this here. So the 3x squared plus 5. Okay, and the product, for the product rule we need to know u dv by dx and v du by dx. So we have to basically now differentiate these two functions. Well, first of all, I'm just going to rewrite this as x to the power of a half, okay, because that's what it is. So du by dx equals, half comes to the front, and then you take 1 off the power and a half, take away 1, it's minus a half. Okay, so du by dx is a half, x to the power minus half. Right, what would dv by dx be? Okay, that's easy, just be 6x. Okay, and nothing else. Okay, now all we need to do is plug into this template the correct bits, really, okay, to work out what the derivative of our function here is. Okay, and so let me do it. Where can I do this with a space? Alright, I'll tell you what, I'll rewrite the template out. Dy by dx equals u dv by dx plus v du by dx. Okay, now first of all, u is the square root of x, or x to the power of a half. You know, I'll rewrite that as x to the power of a half. Okay? Because I may simplify some terms together. dv by dx, what's dv by dx? dv by dx is what we worked out here, 6x, so I'm going to plug that here. Okay? So, that is, I'm going to multiply that by 6x. Now I'm going to add now, what's v? v is this, so 3x squared plus 5 times, what's du by dx? du by dx is this, so I'm going to plug that here. Okay, so a half x to the power of a minus a half. Okay, and so let me clean this up a little bit. Okay, so we'll have, what can I do here? 6. Okay, so here I'm going to do x to the power of a half times x to the power of 1, so add those, so that's 1.5. So x to the power of 1.5, or 3 over 2. Okay, plus, can I, oh, I'm not going to bother cleaning this up, actually, it looks, no I will. Okay, I'll put a half here, and then, well, x to the power of minus a half puts the x into the bottom, so it's 3x squared plus 5 all over x to the power of a half. Actually, let me clean this up even more. 6x 3 to the power x 3 to the power x to the power of 3 over 2 plus, and now I'll just put this as 3x squared plus 5 over 2x to the power of half. That looks a bit neater. Right, but this is now the derivative function of our original function. This is dy by dx. Okay, and this is how you do the product rule. It's great because it simplifies the process. This, you know, what would have took a little bit longer to do, done in a couple of steps. But it's about taking these bits here and putting them into the correct place. Okay, so u times the derivative of v, v times the derivative of u, and adding them together. Okay, and then cleaning it up, or however which way you can. Alright, let's do another one. This one is going to take a little bit more time to do, and just be patient, okay, because we're probably going to have to combine it with the chain rule here as well. Power of 5. Okay, so here is a really nasty, complicated looking function, and you could go ahead and write the binomial expansion of this and then multiply by x cubed and do it that way, but it'll take a long time to do. But notice that it's the product of two separate functions. Okay, here's one of them, and what I've just underlined up to the power 5 is the other function. So u would equal x cubed, okay, and v would equal the rest of it, which is 3x squared minus 5x to the power of 5. Okay, now this, let's differentiate it. Du by dx is just 3x squared. That's simple enough. Okay, so we're going to use that in a minute. Right, this is the nasty looking one, because this is a composite function. So what we're going to do is we'll have to replace this with something. Well, we can't use u because that will confuse the matters here. But remember what the chain rule is: dy by du times du by dx. But I'm just going to do it like this. Let a equal the bit inside 3x squared minus 5x. Okay, and then v would equal a to the power of 5. Okay, so then dA by dx equals 6x minus 5. dV by dA equals 5a to the power of 4. And I'm just going to multiply these two. So dV by dx equals 5a to the power of 4 times 6x to the power of 6x take away 5. Okay, replacing the a back with this. This is just a chain rule using a different letter instead of u, by the way, okay? So this is a chain rule here. Okay, and then that'll be 5 bracket 3x squared minus 5. Oops, x times 6x take away 5. Right, it looks bad, but don't worry, it won't be. Right, I'm just going to rewrite this in a different order. I'm going to put the 5, 6x take away 5 first, and then the 3x squared minus 5x. Okay, now this is dv by dx, and this is du by dx is 3x squared. I'm just going to write above it what u was. U was 6. No, it wasn't. What was it? It was x cubed. And v was equal to 3x squared minus 5x to the power of 5. Okay, now let me rub out all of this junk here. Don't need that. Okay, now we're going to use these in our template for the product rule. Okay, so product rule is to do dy by dx equals u dv by dx plus v du by dx. Okay, so this is going to be fairly long. Right, u is x cubed, so let me write that, x cubed, big bracket. What's dv by dx? dv by dx is all this. So I'm going to have to bung it here. 5, 6x take away 5, 3x squared take away 5x. Okay, plus v, what was v? V was 3x squared minus 5x to the power of 5 times what's du by dx? du by dx is 3x squared. Okay, now let me clean this up. Okay, so that'll be a 5x cubed, 6x take away 5 bracket 3x squared minus 5x plus, let me put this in front, 3x squared bracket 3x squared minus 5x. Okay, now you can leave it like this if you want it. Oh, hang on, I forgot the power 5. You can leave it like this if you wanted to, and this is actually the derivative function. This is dy by dx. Okay, you could use this to go on to work out the derivative function, but I'm just going to clean it up a little bit. Okay, and you don't have to do this next bit, but I'm going to do it now. Okay, first of all, I've got, actually there's probably no point doing this, but I've got this bracket here, and this is to the power of 5, so I can take at least one of these out, right? So I can take the 3x squared minus the 5x out, and then I'd have 5x cubed times 6x take away 5 plus 3x squared bracket 3x cubed minus 5x to the power of 4. It's supposed to be a 4 to the power of 4. And then, you know, you could probably expand that bracket out if you wanted to, or do the binomial expansion, but it might be a good idea just to factor something out, and then, you know, you never know what might cancel. But that is the derivative function. Well, actually this is the derivative function of this in a nutshell. Okay? Alright, so next rule is the quotient rule. We'll look at that in our next clip.